Hello everyone. Welcome back to our channel. If you're passionate about data science, machine learning, or any field that heavily relies on data, then today's video is for you. We're going to dive into a tool that's becoming increasingly essential in the world of data management, data version control, or DVC for short. So grab a cup of coffee and let's get started. But first, let me ask you a question. Have you ever found yourself in a situation where you made changes to a dataset or a model, only to realize later that you need to go back to a previous version? Or maybe you've collaborated with others and keeping track of changes became a nightmare. If that sounds familiar, stick around because DVC might be the solution you need. So, what exactly is DVC? DVC stands for Data Version Control, and it's an open-source tool designed to manage machine learning projects by versioning datasets and models. It works seamlessly with HIP, allowing you to track changes in your data and models just like you would with your code. Let's break it down with a simple example. Imagine you're a data scientist working on a project to predict house prices. You have a dataset containing thousands of records about houses, including features like size, location, and number of bedrooms. Now, as you start building your model, you might want to experiment with different versions of your dataset. With DVC, you can create a version of your data with specific features or a clean version without outliers. That way, if a particular version of your model performs poorly, you can easily go back to a previous version. It's like having an undo button, but for your data. Using DVC is straightforward. You can initialize a DVC project in your existing Git repository with a simple command DVC in it. From there, you can start tracking your datasets. For example, to add a dataset, you would use DVC add data house_data.csv. DVC will create a .dvc file containing metadata about the dataset, allowing you to maintain a history of its versions. One of the key features of DVC is its ability to handle large datasets efficiently. Traditional version control systems like Git can struggle with large files, but DVC solves this problem by storing only the necessary metadata in your Git repository while keeping the actual data in a remote storage solution like Amazon S3 or Google Drive. This means your Git repository stays lightweight and efficient, even with substantial datasets. Let's talk about collaboration. In a team environment, it's common for multiple data scientists to work on the same project. DVC facilitates collaboration by allowing team members to share datasets and models without conflicts. When you push your changes to the remote repository, your teammates can effortlessly pull the latest versions of datasets and models. Imagine you and your colleague are working on the same house prices model. You develop a feature that uses the average distance to schools, while your colleague adds a feature for average area income. Using DVC, you can both work independently on your features, and when it's time to integrate your work, DVC helps ensure everyone is on the same page. To share your updates, you simply use DVC Push, which sends your data to remote storage, while DVC Pull allows you to fetch the latest datasets from that storage. This seamless integration fosters collaboration, reducing the risk of overwriting each other's work. Another crucial aspect of DVC is reproducibility. In data science, being able to reproduce results is vital for validating models. DVC allows you to create pipelines that define the steps needed to go from raw data to a trained model. You can specify each stage, such as data preparation, model training and evaluation, and DVC will track the dependencies between these stages. For example, if you update your dataset, DVC will automatically know which models need to be retrained and help you run those steps without missing a beat. This level of automation and tracking is a game changer for ensuring your results can be replicated by others, or even by yourself a few months later. So, to summarize, DVC is an invaluable tool for anyone working with data in a collaborative environment. It allows you to version control your datasets and models, manage large files efficiently, collaborate seamlessly with team members, and ensure reproducibility in your projects. If you haven't tried DVC yet, I encourage you to do so, especially if you're dealing with data management challenges. If you found this video helpful, give it a thumbs up and share it with your fellow data enthusiasts. And don't forget to subscribe to our channel for more educational content like this. Do you have any questions about DVC or want to share your experiences? Leave a comment below. I'd love to hear from you. See you next time. Happy coding!